Welcome to another video on smart architectural programming, and in this video we'll be focusing on another blind 75 lead code list of problems, in particular the construct. Basically in this problem, given a certain in-order traversal or a pre-order traversal, we need to reconstruct a binary tree from that given data. So first we need to understand exactly what in-order and pre-order traversals are. We have done these before in the other problems regarding binary trees, but just as a quick refresher, we'll go over what they are. Then we'll go over exactly how we can reconstruct using an algorithm a binary tree given pre-order and order traversals of that binary tree. So given that, let's jump into this problem. So before we do that, please remember, if you get any value from this video, please like and subscribe our channel. And if you have any questions, problems, anything that you want to ask us or want us to create a video on, please let us know in the comments below. And with that, let's jump into this problem. So given this particular binary that we see here, right, we'll go over what pre-order traversal is, right? So pre-order traversal basically starts with a simple fact, right? So we first enter the number in the root of the tree, which is 1, right here. Enter that as the first level, right? So all of these traversals and the binary trees in the computer are written as a list, right? So given the traversal is also a list, we're going to tell you exactly how the sequence of this list works, right? How this pre-order traversal is working and how this data is being collected. So 1 is a root node that comes first. Then, as I think we discussed previously, it's middle. Let me actually make it a little more clearer. So it's middle, right, left, and then right. That's the rule regarding pre-order traversal. So middle is the root node. Then we go to the right, which is number 2, right here. So that comes second here, right? And then we go to number 3 over here, right? So number 3 is here. At this point, we're back to the middle point, right? So if we had another node here, we would have gone over there, but since there's no node over here, we go to the last on the right side, the last node, which is 4, and that is how a pre-order traversal works, right? Simple enough, right? So removing all of this, let's move back to in-order traversals, right? You need to understand what in-order traversals are. So let's use a different color. Let's use purple for that. So an in-order traversal works basically quite simply. So first, in-order traversal starts from the first element in the list, that is 2, right? So 2 comes first, right? Then 1, then 1 comes here, and then 3, and then 4. So that's how in-order traversal works basically. It's also very simple. But these difference in timing will help you understand how we can use in-order traversals to construct and pre-order traversals to construct a binary tree given these two traversals, right? So let's start. So we understand that in a pre-order traversal, let's use a completely different color for the final go through. So let's use dark blue here, right? So we understand that a pre-order traversal, in-order traversal starts. So let's just go right back to the top, right? So an pre-order traversal is usually starts from the root node, right? Which is 1, right? So we know 1 is the root node, right? Here. But even if we go and we know then the first element is the left side, which is 2 over here, right? So 2 over here, right? So we know 2 is there as well. But after that, we don't know whether 2 has further branches on its left or right sides, right? So given that understanding, we can't move forward, right? We can't move forward from that point. But we do know one thing, right? In-order traversals, we know exactly how many elements are on the left or the right side. We can make that judgment using the in-order traversal. So using the red color, you'll notice that we know 1 is the middle point, right? Based on pre-order traversal. But at the same time, we understand in in-order traversal, 1 is the division point between the left and the right sides, right? So we know 1 is here. So given 1 being here, we can count on the left side how many elements are there, and the right side how many elements are there. So we know on the left side there's only 2, and the 2 comes here, right? So with that we can make the judgment that after 2 the left side ends, and 3 and 4 are probably on the right side, right? So that is the judgment we made based on that, right? So on the 3 point, then basically you need to do it on all levels. So if you go back to line next 3, right, we understand that 3 is the middle point, and on the left and the right side of the 3 are the left and the right side of this node, right? But there's no left on this side 3, just right. So let me use the red color again. So we cut out 3 here, and we circle 3 here as well. So left side there's nothing, there's only 4 on the right side, so we know there's only 1 element to the right. So that's based on this sequence and understanding of preorder and inorder traversals, we can reconstruct a binary tree quite easily. So given that understanding, right, let's look at our code over here. For this code, first we also need to do a little bit more understanding, in the sense that we need to understand that to reconstruct binary trees from preorder and inorder traversals, we leverage 2 properties of the preorder and inorder traversals that we discussed. Preorder traversals are root, left and right, that's the sequence, and inorder traversals are left, right, root, right? So based on that, first element of the preorder list is the root. We discussed that. That's our approach to this algorithm basically. Then we find the index of this root in the inorder list. That's placed in inorder list into left subtree and right subtree. We talked about that. Once we find the root using the preorder traversal, we can easily find the midpoint and differentiate between the elements in the left and the right of the binary tree at that particular root node using the inorder traversal, right? Then we recursively repeat the process of the left and right hand sides basically. There's a simple recursive solution that we could do to that, right? But that solution basically finds the list of all index of the root, but if the index takes only on, splitting tasks takes on again, so the total time complexity for that would be on square in worst case. But if we use hash maps, which I'm pretty sure you're familiar with at this stage, to store indices of inorder elements, finding the root index becomes O of 1, which reduces the overall time complexity to O of n. So we're going to use the hash map solution to that. So if you can look at the screen right now, let's go over the code quickly. So we inorder hash map, which is a dictionary in Python in most cases. Then we have a helper function that has pre-start, pre-end, in-start, and in-end values basically. And based on that, we've coded out this problem. You can review the code on the screen right now. So in the build tree function, basically, first we check if the preorder or not in order. If there's no preorder and there is in order, or if there's in order and no preorder, then we return none and end our algorithm. But if there are both of them given to us, we create a hash map for quick lookup of root indices, as you can see on line 40. Then we create a helper function in which we see if pre-start is greater than pre-end or in-start is greater than in-end. Either way, we close because that shouldn't be possible. That's not a binary tree anymore. Binary tree must have smaller values on the left side compared to the right side. That's just how binary trees work. So that means we return none because this is not a binary tree. Then we basically find the pre-start value that is in preorder value, and then divide that as the tree node, right? And then run our algorithm as needed. So if we run this algorithm, you'll notice that both of our cases are solved. Yep, both cases were solved. And if we submit it, all of the cases would be solved and the submission would be accepted. So that is how you solve the construct binary tree from preorder and inorder traversal problem in the Blind 75 list of problems. And with that, we're going to wrap this video up and see you in our next video. Thank you.